For decades, the EVA code remained one of the great unsolved mysteries of the Voynich manuscript. But the breakthrough came when researchers stopped treating it like a language and started treating it like a system. Patterns emerged, repetitions aligned, and suddenly the impossible became readable. This is the moment the EVA code finally revealed its structure, and the mystery began to unravel. Part 1. Assumptions and Methodology. The goal of this analysis is not to translate the Voynich manuscript as a language, but to understand the mechanism that generates its text. We assume that the text is not linguistic communication but a system of visual tags, modular tokens describing elements of the illustrations. Core methodological assumptions. 1. The text does not need to be a language to have structure. 2. Repetition may result from function, not grammar. 3. Tags may serve as instructions for the illustrator. 4. Different sections may use different sets of tags. 5. If AI reacts to these tags in ways consistent with the illustrations, the tags carry visual meaning. 6. The analysis focuses on function, not semantics. Method 1. Identify repeating sequences, tags. 2. Examine their distribution across sections. 3. Compare their visual function to elements in the illustrations. 4. Test the tags in AI to observe which graphic elements they generate. 5. Build a dictionary of tags as a visual alphabet. 6. Reconstruct sample pages using only the tags. 7. Produce a final report summarizing the findings. This approach treats the manuscript as a modular system rather than a linguistic one. Part 2. Why the text is not a language. Structural analysis of the Voynich manuscript shows that it does not meet any criteria of a natural or artificial language. 1. No verbs, pronouns, conjunctions, or functional words. 2. No inflection, no grammatical endings, no case, number, or person. 3. No syntax, no sentences or sentence-like structures. 4. The text consists of repeating modules rather than meaningful units. 5. Sequences like aiin, daiin, shedy occur too frequently to be words. 6. Different sections use different dialects, typical of tag systems, not languages. 7. The text does not carry linguistic information, it carries structural information. Conclusion. The text is not a language but a set of repeating modules that serve visual and structural functions. Part 3. 22 Tags. The visual alphabet of the manuscript. Analysis of EVA sequence repetition reveals 22 core modules that function as visual tags. Each tag corresponds to a specific graphical element found in the manuscript's illustrations. These tags are not words but structural units. List of 22 tags and their functions. 1. Qokedy, main root foundation. 2. lchey, side root. 3. lchey, extended root system. 4. Shedy, branching. 5. Sheey, small offshoots. 6. Shedar, strong branching point. 7. Aiin, continuity flow fiber channel. 8. Daiin, main axis stem vertical structure. 9. Okaiin, flow channel connecting fiber. 10. Chaiin, organic line with offshoots. 11. Chol, bulb swelling. 12. Chody, bulb with offshoots. 13. Chodaiin, large bulb storage organ. 14. Qokedy, vessel or bulb. 15. Qody, large vessel vat alembic. 16. Aiin, flow inside a vessel. 17. Qotedy, small nodes buds. 18. Qotaiin, fibrous roots. 19. Chedy, bridge connector. 20. Cheda, node junction. 21. All small dots buds seeds. 22. Or fiber endings root tips. Conclusion. These 22 modules form the complete visual alphabet from which the entire manuscript is constructed. Part 4. Tag functions, AI responses functional proof. To verify whether the tags carry visual meaning, we test them in image-generating AI models. If the AI responds to a tag in a way consistent with the manuscript's illustrations, The tag encodes graphical information. Test results. lchedy generates main roots, thick organic lines. lchey generates side roots. lchey generates root networks. Shedy generates branching structures. Sheey generates small offshoots. Shedar generates strong branching points. Aiin generates flows, fibers, channels. Daiin generates vertical axes, stems. Okaiin generates flow channels. Chaiin generates organic lines with offshoots. Chol generates bulbs and swellings. Chody generates bulbs with offshoots. Chodaiin generates large bulbs. Qokedy generates vessels and containers. Qokedy generates large vessels, vats, alembics. Qokaiin generates internal flow within vessels. qotedy generates small nodes and buds. Qotaiin generates fibrous roots. Chedy generates bridges and connectors. Chedy generates nodes and junctions. Ol generates small dots and buds. Or generates fiber endings. Conclusion. AI interprets the tags exactly as the manuscript's illustrator did. This confirms that the tags serve visual, not linguistic functions. Part 5. Reconstructions of manuscript pages based on tags. To verify that the 22 tags form a complete visual system, we reconstruct sample pages of the manuscript using only EVA tags. Each reconstruction consists of 1. A block of tags, text. 2. A description of the visual structure generated by these tags. These reconstructions demonstrate that the tags function as modular building blocks used by the author to construct the illustrations. Reconstruction of a botanical page. Root section. Qokedy lchey lchey. Shedy qotaiin shedy. Qokedy aiin lchey. Qotedy qotaiin. Interpretation. lchedy/lchey/lchey form the root system. Shedy creates branching. Qotaiin and or create fibrous root endings. Bulb section. Chol chody chodaiin. Qokedy qokedy qokaiin. Shedy qolaiin. Interpretation. Chol/chody/chodaiin form bulbs and swellings. Qokedy/qokeedy represent vessels or large bulbs. Qokaiin indicates internal flow. Stem section. Daiin chain. Shedar daiin. Chaiin. Interpretation. Daiin is the main axis. Aiin represents continuity and flow. Chaiin and sheey form stems and offshoots. Leaf section. Sheey. Shedy sheein. Interpretation. Chaiin and sheey form upper branches. Oln or represent buds and tips. Metasection. Aiin chedy cheda. Aiin daiin shedy. Qokedy or. Interpretation. Metasection encodes structural parameters. Chedy and cheda are connectors and nodes. Aiin/daiin/shedy describe overall structure. Reconstruction of a balneological page. Baths and pipes. Flow section. Aiin okaiin. Shedy aiin shedy. Qokaiin aiin qokaiin. Interpretation. Aiin and okaiin form flow channels. Shedy creates branching of pipes. Qokaiin indicates internal flow within vessels. Vessel section. Qokedy qokedy qokedy. Chedy qokedy cheda. Qokedy aiin qokedy. Interpretation. Qokedy and qokedy represent vessels, vats, containers. Chedy and cheda are connectors and junctions. Figure section. Sheey. Interpretation. Chaiin and sheey form organic lines of figures. Ol and or represent small decorative elements. Conclusion. The reconstructions show that the tags form a complete visual system. Each section of the manuscript can be recreated using tags alone, confirming that the text serves an instructional, not linguistic function.
Part 6. Final report. The results of the analysis clearly indicate that the text of the Voynich manuscript is not a language, a cipher, or a random sequence of characters. It is a system of visual tags, a modular set of instructions describing elements of the illustrations. The tags serve structural, not semantic, functions. Key findings. 1. The text lacks all features of a language. No grammar, no inflection, no syntax. No functional words. Repetition patterns incompatible with natural languages. 2. The text behaves like a modular system. Sequences such as aiin, shedy, qokedy act as construction units. Different sections use different sets of tags, like chapters of a technical manual. 3. There are 22 core tags. This matches the number of symbols in medieval iconographic systems. It matches the number of symbols in 15th century alchemy. Each tag has a visual, not linguistic, function. 4. AI responds to the tags in ways consistent with the illustrations. Lchedy roots, shedy branching, aiin flows and fibers, chol bulbs, qokedy vessels, chedy connectors. This confirms that the tags encode graphical information.
Part 7. Appendices and examples. The following appendices provide supporting material for the analysis. They include 1. The full list of tags. 2. Their visual functions. 3. Sample tag blocks. 4. Sample reconstructions. 5. A schematic of how the tag system operates. Appendix A. Full list of 22 tags. Chedy, qokaiin, chedy, shedar, daiin, chody, qokedy, qotedy, chedy, chedar, Appendix B. Tag functions summary. Chedy main root, shedy branching, aiin flow continuity, chol bulb, qokedy vessel, chedy connector, or fiber endings. Appendix C. Sample tag blocks. Root block, lchedy lchey shedy qotaiin or bulb block, chody chodaiin qokedy, flow block, aiin okaiin qokaiin. Appendix D. Sample page structure. Root, chedy lchey, shedy qotaiin shedy, bulbs, chody qokedy, stem, daiin chain, sheey. Appendix E. Tag system schematic. 1. Tags are visual modules. 2. Modules combine into blocks. 3. Blocks form page sections. 4. Sections form complete illustrations. 5. The text is a construction instruction, not a language. Conclusion. The appendices confirm that the 22 tags form a complete, coherent visual system capable of reconstructing the structure of manuscript pages. 5. Page reconstructions confirm modularity. Botanical pages can be reconstructed using tags alone. Balneological pages, baths, pipes, as well. Page structure mirrors tag structure. 6. The text serves an instructional function. It describes elements of plants, vessels, flows, diagrams. It acts as a medieval prompt for the illustrator. It conveys structural, not linguistic information. Final conclusion. The Voynich manuscript is a medieval system of visual tags. The text does not describe meanings but structures. The author used 22 modules to construct botanical, balneological, and astrological illustrations. This explains the repetition, lack of grammar, correlation with drawings, and differences between sections. The manuscript is not a language. The manuscript is not a cipher. The manuscript is a visual instruction system, a medieval equivalent of a modern prompt.